Okay, sixth grade, our objective today is to talk about zero and negative exponents. So just a quick review from yesterday. Who can remind us, when you multiply the same base, what do we do with exponents? Alyssa? Good, add them. When you divide same base, what do we do with exponents? Emma H? Good, subtract them. What do you do with the coefficients on a problem like this? So what do you do with the coefficients on a problem like that, Mary? Good, multiply. What do you do with the coefficients on a problem like this? Sean? Good, simplify the fraction as much as you can. And don't forget about that roll on the calculator. 3 divided by 12, enter, math, enter, enter is helpful as well. Okay? All right, very good. Okay, let's quickly go over the warm-up. Number 1, Charles. Good, 12 to the 15th. Briar, number 2. Good, 9 to the 11th. Sean, number 3. Good, 8 to the 23rd. Annalise, number 4. Good. Number 5, Mary. Nope. Good. You remember, rewrite the base, then subtract. Do not divide the base. Adam, number 6. Good. D to the 12th. Okay, the second number 1. I know this is kind of weird. Emma M. Good. Jeremy, the second number 2. Good. Donatus, number 3. Good. Alyssa, number 4. Awesome. Any questions on any of those? Okay, Jeremy? Okay. Good. We're good on that? All right, let's go over the homework. Wow, that was the quickest warm-up ever. No, because you want to do it on your own. You can go back to Blackboard and check them because I'm recording, so, or see me and I'll check them. Okay, Matt, when you get to your homework, you tell us number 1. So 4.5. Some of these were a little tricky, but you guys, I'm thinking you guys were okay. Good. Good, perfect. Emma H, number 4. Good. Alyssa, number 3. Good. Number 4, Donatus. Good. Jeremy, number 5. Good. Emma M, number 6. Good. Adam, number 7. Good. Mary, number 8. Good. Number 9, since it's up here, 11 to the 4th. Number 10, 13 to the 3rd. Charles, number 11. Good. Number 12, Annalise. Good job. Number 13, Sean. Good job. Briar, number 14. Good. 12H to the 11th. Matt, number 15. Good. Jeremy, number 16. Great job. Donatus, number 17. Good. Alyssa, number 18. Good job. Number 19, Emma H. Good. Number 20, Charles. Good. Number 21, Mary. Good job. Number 22, Adam. You didn't simplify 15 over 18. 3 goes into each of them. So I would probably take off half a point. And what did, okay, go ahead, Adam. Sorry. Good. You corrected your own mistake. 5z to the 4th over 6. Okay, but before I flip the screen, make sure you have checked up through 22. Okay, Emma M, 23. Good job. 24, Briar. You need to simplify your fraction. That 42 over 28 can be simplified further. Okay. Sean? Good. 3h to the 14th over 2. Mary? No, because when you multiply a to the 5th times a to the 3rd, you get a to the 8th, but there's still an a on the bottom. Remember, simplify the numerator first, simplify the denominator, and then follow the rules from yesterday. Okay? Okay, 25. Sean? Good. Annalise, 26. Good. 3x to the 3rd. Number 27 is x to the 4th. 28. Charles, what'd you get? Say that again? 35. Not 35. You mean 3 to the 5th? Yes. Okay. Okay. That's what I thought. 3 to the 5th times larger. That's okay. Emma H, 29. Good. Alyssa, 30. Good. 11. Donatus, 31. Good. 25. 32. Jeremy. Good. Matt, 33. Good. 24. And then 34. Doug, do you know it? Okay, I thought you had the answer. All right, you got it? Yep, 14. So if you wrote the answer as r to the 14, or if you just put what the question mark is, I'm okay with that. All right, questions on any of the homework problems? Annalise? It should be 3 to the 5th times larger, because you're trying to find out how many times larger the second FAL is. So you would set it up as 3 to the 2nd times 3 to the x, you have to find it, equals 3 to the 7th. So 28 would be 3 to the 2nd times 3 to the x equals 3 to the 7th. You have to find what x is. That's same thing, but it's still 3 to the 5th times larger. No, it gives you 3 to the 5th. It gives you, the way you did it gives you the same answer. You just need to make sure you put that put that 5 back into the variable. Okay. Hold on one second, guys. Hello? Hi. Good, how are you? Oh wait, it's Angela Galliotto. I'm 4019. That's okay. Bye. Wrong number. Okay, Annalise, does that make sense? Yep. Okay. Okay. Anyone else? Need me to go over something? Go back to the previous page? Raise your hand if you got them all right. Yay. Raise your hand if you missed one. Okay, missed 2. Okay, and if you missed something, you guys know why, right? Okay. All right, let's open up our notes. We are on page 16, starting at the bottom. So page 16 of the notes, starting at the bottom. Now, some of you guys, we already talked about a lot of this yesterday, because a lot of you know how to simplify negative and zero exponents. So I'll be interested to see how this goes. So we already did the warm-up. We're going to start with the box where it says negative and zero exponents. First little definition here is for any non-zero number A, anything to the 0 power is 1. The reason is, if something's to the 0 power, there's one way to write it. You write it 0 ways. It does not exist. Anything to the 0 power is 1. If you type that in your calculator, it will tell you that the answer is 1. So for fun later, if you want to type that into your calculator, you can put 3 to the 0, hit enter, it's 1. There's one way to do it. There's 0 ways. Adam. Yeah. No, 0 to the 0 power is 1. Does he give you an error? Does he give you an error? Wow. The calculator gives you an error on that.
Oh, yeah.
Yeah. But technically anything to the 0 power is 1. You will never see a problem that gives you 0 to the 0. That's a very good question though. Okay. Okay. Mary. to the 0. Yep. Yep, it's 1. Okay, shh, Adam. Shh, Annalise. Well, you're not multiplying it by 0. Yep. Okay, let me do, we're going to do examples. Okay, second definition. For any non-zero number a and any integer n, a to the negative n power is equal to 1 over a to the n. For any non-zero number a and any integer n, a to the negative n is equal to 1 over a to the n. In other words, we're going to talk about today, you cannot leave your answer with a negative exponent. You cannot. To get rid of a negative exponent, whether it's on the top or on the bottom, if it's on the top, we always put a 1 on the bottom. We take the power, which is this whole thing that's negative, we switch it to the other side. When you switch it to the other side of the fraction, it becomes positive. So let me show you some examples. I want you to add these underneath that little box. So, Sean, 2 to the 0 power would be what? Good. Anything to the 0 power is 1. Adam, you writing these? Okay. Second example, I want you guys to write down 4 to the 0 times x. 4 to the 0 times x. So, Doug, 4 to the 0 is what? No. 4 to the 0 is 1. So you'd have 1 times x, which, as Doug said, the answer is x. If something is to the 0 power, only that term is 1. If you have something else next to it, you have to multiply. 1 times x, you get x. Okay, third example. 3 to the negative 6th power. 3 to the negative 6th power. Do not leave your answer as negative exponents. So the very first thing you need to do is put a 1 underneath 3 to the negative 6th power. The entire power, I'm going to circle, it moves to the bottom. So I circle the entire power, it moves to the bottom. So when you move it, it becomes 1 over 3 to the positive 6th power. When you switch it to the other side, all we're going to do today is make it positive. They are equivalent. 3 to the negative 6th is the same thing as 1 over 3 to the 6th. You never leave your answer with negative exponents, ever. Annalise? It's the same thing. It's very hard for me to explain that to you. This is one of those things in math, it just is. If you were to type this in your calculator and type this into your calculator, Annalise, they're equivalent. They are the exact same thing. You're just not allowed to leave your answer as negative exponents, ever. It's kind of like when we talk about standard form in Chapter 8, the first number is not allowed to be negative, just because. It's one of those rules in math. Okay? Sean? That's okay. One over 3 to the 6th, b 3 to the 6th? No, those are completely different. Because if you divide, let me get the calculator real quick. Okay. So look, Sean, if we do 1 divided by 3 to the 6th, and I hit enter, you get that. If I do 3 to the 6th, oh, that's real good, right? Oh. Okay, if I do 3 to the, come on, Carrot, we need you, to the 6th, hit enter. That's not the same. But if we do 3 to the negative 6th, they're equivalent. Yeah, that's okay. Okay, hold on. Raise your hand, guys. So, yes. I guess we could call it simplified because you're not allowed to leave your answer with negative exponents, ever. Does that help? Adam. Sorry, Matt. Yeah, could. This is just the more condensed and simplified version of how you write it. I understand what you're asking, but you want to keep it as simple as possible. Okay, so you're not driving yourself crazy. Okay. If you have more questions on that, let me know. Emma? Okay, think back to yesterday. How do we leave all of our answers as exponents? So you're not, this is the answer. You don't go any further. You could not solve it. You can simplify it. Remember, the only time you can solve something is if it's in an equation, Emma. So if you had like 1 over 3x equals 4x minus 10, then you could solve that. But we're not doing things that difficult yet. Okay, we're just simplifying exponents. There's not an equation. There's not anything to solve. Jeremy? Switch it. Yeah. Yeah. Annalise? Yeah, yes, of course it's going to get harder. All right, let's go to some examples because you guys will see that. Okay, flip over to page 17. These are just very basic. Of course, I'm going to make them, like Annalise said, I'm going to combine everything and make them harder. If I didn't do that, this would not be an accelerated math class, and that would not be fun, right? Okay, letter A, 4 to the negative third. Put a 1 on the bottom, circle the power, the entire thing moves or switches to the bottom, you make it positive. So the answer is 1 over 4 cubed. That's completely simplified. Remember how I showed you in the calculator? Those are equivalent, but the completely simplified answer is 1 over 4 to the third, no negative exponents. Okay, letter B. The very first thing I want you to do is put a 1 on the bottom. Let's get rid of the negative exponent first. Circle the power that has the negative exponent. Draw an arrow to the denominator. So we have n to the 0 over m to the 5th. Now what? After we move the negative exponents, Briar. Yep. N to the 0 is 1. So your final answer is 1 over m to the 5th. Anything to the 0 power is 1. But before you do that, you want to move your negative exponents. I'm going to show you in a couple minutes what the order of operations for harder exponent problems is to make the steps a little bit easier. Emma? No. You'll see examples where, okay, if I give you a problem like this, Emma, how would you do that one? Don't say the word flip. You're going to move or switch it. You're going to circle this. This moves to the top. You always move it to the opposite side of the fraction to make it positive. So it doesn't matter where the negative exponent starts. You just move it to the opposite side. That make sense? Okay. Annalise? Nope. Why would you move 8 to the bottom? 8 does not have a negative exponent. You only move something that has a negative exponent. This is to the first power. You need to keep that where it is. Okay? Okay, letter C. Put a 1 on the bottom. There's only one thing we have to do here. What is that, Matt? Wouldn't what go with Y? This one? On this one? Yeah. Yep. So tell me what we're moving. Good job. So y to the negative 8, this is kind of like what Annalise was asking. That's the only thing, the only term I should say, that you're moving to the denominator. The negative exponent goes with y. So we have 13x over y to the positive 8th power. You only move the term that has a negative exponent. Any questions on that one? Mary? Okay, who can explain why don't we move the whole thing? Ryer? Good. The only term that has a negative exponent, Mary, is the y. The 13 is to the first power. The x is to the first power. Don't move something that has a positive exponent. If you do move something that has a positive exponent, it becomes negative, and that's not good. You know what I mean? You don't want it to become negative. Okay? Annalise? Yep. Yep. We're getting to them. We're getting there. Let me do some more examples. We're getting to them. Okay, I want you guys to do D, E, and F. D, E, and F. Go ahead and try them. These are pretty easy. So just do D, E, and F. Zach and Justin, make sure you guys try these too since you're listening to this. Try this one again. Try this one again. Good job. Remember, guys, you're only moving what has a negative exponent. Try that again. Try that again. You're only moving what has a negative exponent. Good job. Good job. Good job. Okay, letter D, Briar, what did you get? Good, 1. Sean, what did you get for letter E? Good. Sean, can you tell us why does the 2 stay where it is? Good. The 2 is to the positive first power. Do not move something that's to a positive power, or exponent, I should say. Okay, Annalise, what about letter F? Good. 3y over x to the 4th. The only term that gets moved to the bottom on that one is x to the negative 4th. When you move it, it becomes positive. You okay, guys? Okay. Any questions on those 3? Okay, next example is kind of weird, but it's good to do. So they now want us to rewrite the expression without using a fraction bar. So how do we rewrite letter A without using a fraction bar? Matt, what do you think? Nope. That's still technically a fraction bar. Briar? Go ahead. No, but you're close. Think about how you just said that. Go ahead. No. Shh. Raise your hand. Sean. Good. 15. This is what Briar meant. He just didn't say it right. So if you have to write it without fraction bars, all they want you to do is take this 15 and move it to the top. If you move it to the top, that positive 1 that's above the 15 becomes a negative 1 because you're switching it to the other side. Correct. That's why I don't like this example. They're forcing you to use negative exponents here. The book wants you to understand how to use them. That's the whole point of switching it from a positive exponent to a negative. So you know how to do it both ways. Annalise? Okay, hold on. Let me do another one. It'll make more sense. Adam? That's different. Correct. That's a different different form, different term. Yeah, I mean, wait, I'll get to that in a couple sections here from now. So we'll have that discussion. Mary, go ahead. Shh. Okay, what's B? Nope. They're not the same base. You can't subtract exponents because the bases are different. You know what I mean? Alyssa, do you know what it is? Okay. Raise your hand if you know what B is, because I know some of you guys like to work ahead. Donatus? Where'd you get 7 from? Donatus, wrong letter B. Good job. Okay, who can explain how how Donatus got that? Emma H? Yep. To get rid of the fraction bar, all you need to do is move the denominator to the top. If you're moving it to the opposite side of the fraction, remember the exponent's becoming negative. Doug? Go ahead, C. Good. Same thing. Take the bottom, move it to the top. When you move it, the exponent becomes negative. Okay, Alyssa, what do you think about D? Good. 3C to the negative second. Same process. Move the denominator, move it to the top. When you move it to the opposite side of the fraction, it becomes negative. Annalise? Yep. Nope. They want us to rewrite it without using a fraction bar. Annalise, this is equivalent to this. This is equivalent to this. They are all equal. Because if we put it back so that there's positive exponents, you're going to get back to the original problem. They just want us to write it without a fraction bar. Sean, are you okay? Okay, just making sure. You had a confused look, just checking. Any other questions or comments on those? Okay, let's go to example 3. These ones make much more sense. Okay, example 3, letter A, it says find the product or quotient. Write your answer using only positive exponents. Very first thing on letter A I want you guys to do is put a 1 on the bottom. Move any negative exponents to the denominator. So 6 to the negative 4th gets moved to the denominator. We have 6 to the 12th over 6 to the 4th. Now what? This is from yesterday. Adam, now what? How'd you get that? Good. When you divide same base, subtract exponents, leave the answer in the numerator because we don't have any negative exponents that we're working with. So when you subtract, you leave your answer in the numerator. Okay, Charles and Doug, do you guys have a question? Is that why your hand's up? Okay, go ahead, real quick. You could do that. So letter A, instead of moving the negative first, you could say, well, we're multiplying same base, add exponents. There's a lot of ways to do these problems. I try to stick with the same order, just like with solving equations. It doesn't matter the way that you approach it, as long as you understand, do not keep negative exponents in your answer. Sean? Okay, go ahead, real quick. Yeah, we're going to do that in a little bit. Yeah. All right, letter B. What do we need to move? What do we need to move first? Briar. Good. I'm going to circle this. Just the end to the negative 4th. We're moving it to the bottom. Why does the 7 stay where it is? Alyssa. Yeah, the 7 is really to the first power. Leave that where it is. So we have 7 over n times n to the positive 4th power. Now what? Now what, Adam? Good. So the answer is 7 over n to the 5th. Mary. Yep, we're getting there. Annalise? Yeah, because it's a multiplication problem in the numerator, so it's still going to be a multiplication problem in the denominator. You're just putting it next to it. Jeremy? Yep. Yep. Okay, go ahead and try the closing, and then I'll get you guys to the harder problem. So there's 2 problems in the closing. Go ahead and try those. And then if you finish, take out your notebook or a piece of paper for the harder problems. So if you're finished, take out your notebook or a piece of paper for the harder problems. Don't close your notes because we still need them, but just shift over to a notebook or a piece of paper. Okay, letter A on the closing. Emma M., what did you get? Good. Charles, letter B on the closing. Good. 7 over D to the 6th. Questions on either of the closing problems? Too easy. All right. In your notebook or on a piece of paper, I want you to title it Lesson 4.6, and then at the top put Power of a Power Rule. Power of a Power Rule. So lesson 4.6, I'm just adding on some notes. Power of a Power Rule. I showed you one of these yesterday, but I'm going to make them harder. The book doesn't have this, but you guys can do it. So after you write down Power of a Power Rule, I want you to write down number 1, but don't do it yet. Briar, question? Yeah, we're going to do that in 1 second. Hold on, we're getting there. Okay, Power of a Power Rule, number 1. Very first thing I want you to do is put a 1 above the 3. If it's power of a power, do you guys remember from yesterday, how do we get rid of the parentheses? Annalise? Okay, but what are you multiplying it by? What are we multiplying the 4 by? You gotta be more specific, because I would say no to what you're saying right now. Remember, this is an exponent. Briar, what are we multiplying it by? Good. So, Annalise, I don't know if that's what you meant. It just sounded like you meant to the bases. You need to multiply an exponent by an exponent. Yep, you cannot multiply by the base. So we get 3 to the 4th, x to the 8th. The power of a power rule tells us when there's parentheses, to get rid of an exponent above parentheses, you multiply that exponent by the other exponents that are inside parentheses. Power of a power rule is the time when you multiply exponents. So if you want to put underneath that, I'm going to put a little arrow. Multiply exponents, I'm fine with that. This is the last rule of exponents. Okay, write down number 2. 7 to the negative 2nd, x to the 3rd, x to the negative 1st, all to the 2nd power. Oh, I'm going to give you some hard homework. So yes, Jeremy. It's not going to be as easy as yesterday's homework. Oh, man. Well, it's pretty easy, but you guys are ready for a challenge. You had a little break yesterday. All right, well, I'm going to tell you you're ready. Okay, number 2. First thing you want to do is get rid of the parentheses. So I'm going to circle the exponent of a 2, and that gets distributed. So it gets distributed to each of these exponents. First step, get rid of parentheses. So we have 7 to the negative 4th, x to the 6th, x to the negative 2nd. What do you think I'm going to tell you to do second? Ooh, a lot of hands. Annalise. Put a 1 on the bottom. What are we circling and moving? Emma H? Good. Circle the terms that have negative exponents. I'm going to draw an arrow. We're moving them to the bottom. So we now have x to the 6th over 7 to the 4th x to the second. Now what? Now what, Briar? Think about the rules from yesterday. Hint, hint, divide. And you're dividing same base. What do you do, Briar? Careful. You just did this for homework last night. Sean, what do we do? Yep, subtract them. So our final answer would be x to the fourth over 7 to the fourth. Briar, did you just forget that? Okay. Divide same base, subtract exponents. Always. Mary. In this step. Yeah. Remember, like I said before, there's a lot, just like solving equations, there's a lot of ways to get to the answer. I'm going to always try to be pretty specific here and do the same thing all the time. Yes, I'm just being consistent. You guys can do it up here if you want. Annalise? Yep, always has to be the same base. Yep. Anyone else? That's the final answer. Okay, I want you to write underneath that in your notebook. This is the order of operations for exponent problems. So I didn't title this. If you want to write down, this is my order of operations for exponent problems. The book does not give one. But, what'd you say? What do you mean? Oh, yeah. You could think of that. Yeah, I like that. So this is my order of operations of exponent problems. I'm going to show you guys some harder problems tomorrow. So this is the order that you solve them in. Step 1, get rid of parentheses. Step 2, get rid of negative exponents. Step 3, simplify, which could mean a lot. Step 3 could mean when you divide same base, subtract exponents. It could mean when you multiply same base, add exponents. So step 3 could mean a lot of things. Adam, we're not done. So step 1, get rid of parentheses. Step 2, get rid of the negative exponents. Step 3, simplify. I want to give you guys one more problem to try. Okay, can I move this? Okay, one more problem. I want you guys to put underneath that, in parentheses, 5a to the 0, b to the 4th, all over c to the negative 3rd, all to the 2nd power. Okay, go for it. Get rid of parentheses first, move negative exponents, and then simplify. You guys can do it. Yep. Yep. When you get rid of parentheses, that exponent needs multiplied to every single exponent. Oh, you got it. Your 5 should have a 2 on it, though. You forgot to distribute the 2 to the 5. Yeah. Don't forget about that. Good job. Perfect. Much better. Oh, wait a second. Anything to the 0 power is what? Yes, that shouldn't be there. Hold on 1 second. What is that? Why is that a 0? No, you need to do that again. Shouldn't have a 0 in your answer. Nope. These two terms need fixed. Nope, we forgot something. This needs fixed. Okay, let me go over it so we have time here. Okay, so here's where I saw some mistakes. First of all, this 5, you need to put a 1 above it. So the very first thing you should do is put a 1 above the 5. This 2 gets distributed to every single exponent. Okay, so I tricked some of you by accident. Every single exponent. So your second step is 5 to the second, a to the 0, b to the 8th, over c to the negative 6th. That was step 1. Get rid of parentheses. Charles? That's fine. I'm getting there. You can. So after you get rid of parentheses, move negative exponents. This gets moved to the top. So we have 5 to the second, a to the 0, b to the 8th, c to the 6th. Step 3 is simplify, which in this case would mean get rid of the a to the 0. Anything to the 0 power is 1. So, as Charles said, you don't have to go in my order, but I try to be consistent. Get rid of parentheses, move negative exponents, and then simplify. That is the final answer. Jeremy, go ahead real quick. Anything to the 0 power is 1. Well, why? Times 1 doesn't mean anything, right? It's still the same problem. You know what I mean? You can write the 1 there if you want, but to me, that's not completely simplified. Okay? Mary, go ahead real quick. What do you think? Yeah, whenever there's not an exponent there. If it's a number or variable and there's not an exponent there, Mary, put a 1 in. Okay? Annalise. Five times. If a number is next to a variable, it always means multiplication.
Yeah, but if it would it matter if it was 5a?
5a is the same. 5a times b is the same thing as 5 times a times b. It's the same thing. Okay, we'll do more of these harder ones tomorrow. Homework is homework packet 4.6, numbers 1 to 28. I don't like the last 3 problems. Don't do those. And then homework packet page 60, 8-4, 1 to 15. So before you guys pack up, please write this down first of all. Secondly, look at page 60 in your homework packet. I want you to circle or put a box around. It's the second section, 8-4. It uses power of a power rule, 1 to 15. And then I need to explain something to you guys on page 60. It won't take long. These are pretty short. Everyone look at page 60 and look at number 8. Everyone look at number 8. Okay, everyone just look. So see number 8, what would you do first if I was not guiding you through this? Sean? Okay, so distribute to each of them. So x to the 15th, y to the 9th, x to the 2nd, y to the 10th. Parentheses are gone. Sean, that's what you meant, right?
Oh, yeah.
Okay. Then what would you do? Doug? Easy? Briar, did you say no, you don't get it, or is that easy? Okay. So if they're mushed together, you just multiply. There's a multiplication symbol there. Got it? Annalise? Yep, that's what we just did. We combined them. Okay. Alyssa? Shh. Yeah. Yes. 8-4. Make sure you guys do in your notebook on a separate sheet of paper. So I'm going to put, hold on one second, Charles, on loosely for page 60. Charles, number 1 on 8-4? Is that what you're asking me about? Oh, on the easy ones, you don't need to show your work. Alyssa was just asking about ones like this. Use a separate sheet of paper for problems like this. Use your common sense. You guys should know by now when to use other paper. Adam, right? Okay. Mary, go ahead. Real quick, because we got to go. No, because I did it with you. Doug? You do whatever you need to show work.